What is the wavelength of light? This question is widely misunderstood in physics. The erroneous answer goes like this. The length of a wavelength is determined by the rate of electromagnetic oscillations in light waves. In fact, the speed of electromagnetic oscillations in photons never changes. All photons are identical, and they all oscillate at the same speed. Electromagnetic oscillations push photons forward at the constant speed of light and have nothing to do with the wavelength of light. All kinds of light are entirely made of moving photons and nothing else at all. And all photons move at the same speed in straight lines, albeit in all directions. The wavelength of light refers to the length or distance between moving photons in a given ray of light. This real, physical distance between moving photons is well studied in particle physics and is measured in nanometers. For example, the distance between moving photons in red light is about 700 nm, and in green light about 550 nm. This can be measured with great precision in a spectroscope. As light is absorbed into objects, newly created light is emitted. For example, a yellow beach ball will emit photons moving with a distance between them of about 580 nm between them. When the photons from the yellow beach ball reach our eyes, we see the color yellow because the wavelength is 580 nm. That wavelength coming out of the beach ball is immutable. It can never change until absorbed into the eyes or into some other object. When scientists see light coming from distant stars or galaxies, the light usually appears a little reddish. This is known as the redshift. But if the speed of light is constant, how can the light change to a redshift? The answer is simple. As a ray of light travels through space, it thins out because the photons in the light ray will be gradually moving apart like the growing face of a cone. So as the photons thin out, the distance between any two moving photons will increase. The greater this distance, the redder the light. A redshift simply means the wavelength or distance between the moving photons has increased, but the speed of the moving photons has never changed at any point. More information can be found here.